Okay, so at the bottom of that second page of your packet, we're going to summarize everything we talked about in yesterday's lesson. We're going to talk about what each part of that equation, what transformation it causes. We're going to talk about those patterns we saw with our vertex, our axis of symmetry, and our range values. So we're going to get that all in one nice spot for you. So let's start with actually what we did first. Our very first example we did yesterday, we had our x squared, and then we added 3 onto the end of it. What happened to our graph when we added 3 on after the squared part? Where did it go? It went up, right? All right, so if we have a plus, and I'm just going to put that generic k there. We had a 3 in our equation. It could be plus whatever number we want. If we have a plus k, our graph goes up. Now, we didn't graph it yesterday, but we talked about, well, hey, if plus 3 made the graph go up 3, what would minus 3 do? It'd make it go down. And I'm hoping you're noticing some of the similarities between the transformations we did with our exponentials in Unit 1 and now our quadratics in our third unit. All the transformations are the same. Our equation just looks a little different, but all the transformations are the same. So if I add or subtract after my squared term or outside of my squared term, that's going to move my graph vertically up or down. Then what we did next was we added 3, but it was part of that squared term. It was inside the parentheses, and it was part of the squared term. What happened when I added the 3, though? Which way did it go? We saw it. We graphed it. Which way did it go? It went to it was our second example. Which way did we go in our second example? It went over. Which way? It went to the left, yeah. So it's the same thing we saw with our exponentials. When we added something in our exponent, it went left. When we subtracted, it went right. So for this piece, maybe I'll put a little brace there. If you have x minus h, it goes to the right. It goes to the right, whatever h is. I know it's opposite of what we think should happen, but it was the same thing with the exponentials. Same thing we're seeing here. We graphed it yesterday. We saw, and we even had the calculator to verify it for us, when we were adding inside that squared piece, we went to the left. We saw it. We graphed it. All right, and then we finished up with multiplying. And I'm going to go down this way because the multiplying ones, A can do several different things for us. The first thing we looked at is what happens if I multiply by a negative. So if A is negative, what happened to our graph? That was our third example yesterday. What happened when we had a negative in front of our squared term? It flipped upside down, right? It opened down. So we called that a vertical reflection. There is such a thing as a horizontal reflection. We just don't get there in Algebra 1. In Algebra 2, you guys will do the horizontal stuff. Algebra 1, since it's the first time you're really working with transformations, we stick with the vertical. Then when you guys get to Algebra 2, you'll see these things again, and you'll start throwing in the horizontal stuff. All right, so if A is negative, no matter what, even if it's just a negative sign or if it's a negative 2, if it's a negative 2/3, you will have a reflection no matter what, okay? Now, if that A value then, aside from the negative sign, and maybe I might throw this in this time, if the absolute value of A is bigger than 1, so ignoring the sign basically, because remember, absolute value is the distance from 0. So absolute value, that result will always be positive. So basically, if I ignore the sign, whether it's negative or positive, if that value is bigger than 1, that's when our graph went up faster, our graph looked skinnier or more narrow, because it's being vertically stretched. It's being vertically stretched. So our graph looked a little more narrow. We multiplied by 2 yesterday in example number 4, and our graph got a little more narrow. Then our last transformation that we have to worry about, and again, I'm going to stick with the absolute value piece. I didn't do that when we did the exponentials, and then for some of us, we had a hard time picking out when it was a reflection and a stretch versus just a reflection or versus just a stretch. So by putting those absolute value bars in there, basically we're saying, hey, ignore the sign. If it's negative, ignore it. Just look at that number piece. Just look at the number value of A, regardless of sign. My notation there says A is smaller than 1, but it's bigger than 0. We have to be careful here. We can't just say A is a fraction or a decimal, because there's fractions and decimals that are bigger than 1. If I have the fraction 3/2, for example, 3/2 is bigger than 1. So 3/2 would fall into the stretch category. So we have to be careful in thinking that a fraction is going to get us our compression. So if we're between 0 and 1, ignoring the sign of A, it's a vertical. We've talked about this before with our exponentials. I learned the word compression, but over the last few years, though, the word shrink has been used. I don't care which one you use. We talked yesterday that different teachers in this department use different phrases for it, so I want to make sure you guys have heard both. So those are all the possible transformations we have. Now, we also noticed yesterday, though, super key point on our graph was the vertex. If we can find the vertex, that makes life really, really easy. So the vertex is always an ordered pair. And the vertex always relates to our left or right movement, comma, our up and down movement. So this would be left or right. The K is the up or down piece. So if you know, you pick out your transformations, if you know that your graph is going to go right 2 and up 5, that's giving you the directions to your vertex, that middle part of your graph, or your high point or your low point, however you want to see that. Now the axis of symmetry. We also noticed a pattern yesterday. Axis of symmetry, remember guys, it is a vertical line, so we have to have the x equals. Don't get lazy on your practice and just start writing a number there. It has to be an equation because it's a line. If I just put a number for the axis of symmetry without the x equals, I don't have a line, I just have a number. I don't even have a point on my graph. I just have a number that I can't even graph. Now the axis of symmetry is x equals, and what we saw yesterday, I was drawing a lot of lines yesterday, it was always the x value of your vertex. Because remember, the axis of symmetry goes right through your vertex. So it's whatever the x value is at your vertex. Axis of symmetry is x equals, so we need the x value. The other piece the vertex was handy for was for our range. Our range was always y could be greater than or equal to, or less than or equal to, depending upon how your graph opens. Opens up or opens down. And then for some, you're like, okay, Miss Golly, I get the greater than part, I get the less than part. I know how to tell that. But where were we getting that number at yesterday? I'm going to scroll up for just a second. I will put this back. I know not everybody has it down. But if you take a look, for example, at number 4, our range in part E, we had a 0 there. There was a 0 for our y value of our vertex. Same in number 3. We had a 0 for our range in part E. There's a 0 for the y in our vertex. Same thing if I go to number 2. 0 in the range, 0 for the y in my vertex. As I look at number 1, we chose 3 for our range. 3 was the y value of my vertex. So when you go to decide your range, you want either your highest or lowest y value, and that is, I'm going to put a K there. That's the y value at your vertex. So most of the pieces that we needed to find yesterday, we don't need the calculator for. We don't. We can pick out the transformations. From the transformations, we can pick out the vertex using our left, right, and our up, down. Axis of symmetry comes from our vertex, and the range comes from our vertex. So the only thing we really need the calculators for still at this point today, where we're at with our graphing, is to get those couple extra, I'm just going to scroll up a touch here, just those couple extra values that are outside or that are around your vertex. That's the only thing we need it for. By the time we're done with this unit, you're going to be able to graph these without needing to jump to the calculator. That's our end goal. We'll be able to find enough pieces just using our algebra that we won't have to jump to the calculator. Okay, so as you work on your assignment today, I'll be giving you assignment 1 here. Let me pull that up real quick. So as you work your way through assignment 1 today, it looks pretty similar to our notes from yesterday, our examples. I would have out the summary that we just did. The first thing you want to do is pick out your transformations. From those transformations, you can find your vertex. You can find the axis of symmetry. You can tell if it opens up or down. What's the only thing that's going to cause my graph to open down? Which transformation? The reflection. Yeah. That negative sign in front of the squared term. So if you look at number 2, for example, on assignment 1. Oh, and it just disappeared, my circle. So the only thing that's going to cause us to open down would be that negative sign, that reflection. Okay? And then the domain and range, again, you can pick out the range from using the vertex. So again, the only time you need to really jump to the calculator is then when you go to make your table of values, and you can graph on the calculator just to double check yourself. Okay, so I'm going to go ahead and get you out assignment 1.